Hi everyone, and welcome to today's crash course on the periodic table of elements part 2. So in this part, remember that this video is actually intended for secondary 4 students in the ST Science program. In the first part, we had talked about the periodic table of elements, groups, and periods, kind of a 101 example of what the periodic table is all about. And now, period 2, we're going to talk about the actual squares within the periodic table, Lewis notation, and the Rutherford-Bohr atomic model. So let's dive in. So let's take a look at an individual square in a periodic table. So as you can see here, we have the very first element on the periodic table of elements, hydrogen. And as you can see, there is a letter and a word underneath. So we're going to explore these in more detail. So the first thing that probably stands out to you is that big letter, the big H. And this is called the chemical symbol. So a chemical symbol can be one uppercase letter, like in this case, the capital letter H, but it can also be in carbon, nitrogen, oxygen, fluorine. These examples that we have here, they're all uppercase letters, but we can also have chemical symbols that are made with 2 letters, an uppercase and a lowercase. Always uppercase, always lowercase. And what's cool about the chemical symbol is that no matter where you are on the planet, no matter what language you speak, the symbol, the chemical symbol, remains consistent no matter what language you are. So that's the beauty of it. It's kind of this universal language between scientists. So if you're in Poland and you're in Ukraine, or you're in the United States, or you're in Canada, H will always mean hydrogen. The only difference is that the translation is going to be a little bit different based off of your language that you speak. And underneath the chemical symbol is the element's name. And so as you can see here for H, it's hydrogen. And so the name of the element, this is the part that changes based off of the language that you speak. So in another language, like if we were in Mandarin or if we were in Japan, hydrogen would be translated into that language, but the chemical symbol would always remain the same. What is the symbol and name of the first element in period 2? Is it A, beryllium, Be? Is it B, its symbol is Be and its name is beryllium? Is it C, its symbol is lithium and its name is Li? Or D, its symbol is Li and its name is lithium? The answer is D. Its symbol is Li and its name is lithium. So remember, the periods in our periodic table are the rows. So if I look at period 2, I look at the second row, and lithium is right here. Its chemical symbol is Li. Remember, an uppercase letter and then a lowercase letter, and then its name is underneath, lithium. So now let's look at the 2 numbers that are within these squares. And so the first one we're going to talk about is the atomic number. Now, the atomic number is actually super duper cool because it does 2 things. First of all, the table of periodic elements is actually organized based on the chemical number. So you'll see that hydrogen is the first element in the periodic table, and then calcium is number 20. So if you were to count all of the elements across a period, the 20th element, when you got to number 20, would be calcium. But the other thing that's cool about the atomic number is that it represents the number of protons in the nucleus. And it's really important to remember that those atomic numbers are always going to be whole numbers, okay? So you're not going to get a decimal. So the atomic number is the number of protons in the nucleus, and it's also the number of electrons because these are atoms that are neutral. So we want to make sure that protons and electrons, they are equal. So if there's 1 proton, there will also be 1 electron. If there's 20 protons in calcium, there will also be 20 electrons. The atom of which element has 16 protons? Is it A, fluorine, B, sulfur, C, chlorine, or D, oxygen? The answer is B, sulfur. So remember that 16 is the number of protons in the nucleus, but it also means that it's number 16 on the periodic table. So if you were to count across those whole numbers that are in the corner, you will get to number 16, which is sulfur right there. So the last number in this square for every single element on the periodic table is called the atomic mass. And so the atomic mass will have decimals, and it is measured in units or atomic mass units, or you'll see the abbreviation AMUs. So there you have it. We have talked about what is inside every single one of those squares. the symbol, the chemical name, the number of protons in the nucleus, which is also our atomic number, and we also talked about the atomic mass. We've also discovered and discussed at length about the number of electron shells that are given, as well as valence electrons according to our groups and our periods in the periodic table. And why is this important? Why do we need to know all this? Well, it can help us draw, first thing, Lewis notation. And so Lewis notation, Lewis dot notation, needs two things. It needs the symbol of the element, which are given to us here in the periodic table, and the number of valence electrons. Now, if you remember from part 1, we talked about how the number of valence electrons is represented by our group numbers, which are the top of every single row. So let's look at a couple of examples. So let's do a couple of examples of Lewis notation. So let's use our first example. Let's do lithium from our first question. Okay, so remember, lithium, we need the symbol of the element. So we have an uppercase L and a lowercase I, just like it's written in the periodic table, and we need to find it. So it's right there, and it's in group 1A. So because it's in group 1A, we know that it has one valence electron. And so that's going to represent our 1 dot, and we are just going to put it right here. And that is our Lewis dot notation for lithium. So for our next example, let's do carbon. So carbon has the chemical symbol of an upper letter C, an uppercase C. And if we look over where carbon is on our periodic table of elements, it is in group 4A. So if we go to find carbon, okay, and it's right up over here, that means that it has 4 valence electrons. And so what I like to do as a general rule is I start from the top and I go around clockwise. So I have 1 dot, 1 dot, 1 dot, 1 dot. So it has 4 valence electrons, and that is my Lewis dot diagram for carbon. And for our last example, let's choose argon. Now, argon is one of our noble gases. So remember, it's all the way at the other end of the periodic table. And if we look at the group, it is up at the top, it is 8A. And so the chemical symbol we always need to write, which is A in an uppercase and R lowercase. So that's our chemical symbol. It has 8 valence electrons. So as a general rule, you go around just like we did with carbon, 1 on each side, and then you go back and you do your 5, 6, 7, 8. So this is generally what a Lewis diagram will look like with 8 valence electrons. And as you can see in the periodic table, you're not going to get more than 8 valence electrons. So that is a full dot diagram of argon. Which version of Lewis notation is correct for beryllium? Is it version A, version B, version C, or version D? The answer is version B. So if we look where beryllium is on our periodic table, it is right over here next to lithium, and it is in group 2A. Now look at the chemical symbol. It's not B, it's not Bi or Br. It's B uppercase and E lowercase. And if it has in the group 2, that means it has 2 valence electrons. And so there's 2. Does it matter where the dots are? No, as long as you have 2 dots. So in the diagram of the question, it was like this, but you could also do it if you did the clockwise method like this as well. As long as the valence electrons are accounted for, you're good to go. We can also use the information from the periodic table to construct a Rutherford-Bohr model. And so in order for us to do that, which is in our next examples, we need a couple of things. We need 3 things, actually. So we need the number of protons and electrons. And so if we're looking at number 6 in this example, we're going to be looking at carbon because carbon is number 6 in the periodic table. We also need the number of electron shells. Now remember, the number of electron shells corresponds to the period. So our rows in our periodic table. And then finally, we also need the number of valence electrons. Now, because we've been doing Lewis notation, we remember that the number of valence electrons is at the top of every single one of our groups. And so we are going to work on the example of carbon. Now, don't worry. I cut off a little bit of the periodic table here just to give us some more room because Rutherford-Bohr models are kind of a little larger than Lewis dot, but don't worry, it's still there, it still exists. So let's jump into our example of carbon. Okay, so we're going to start off with the number of protons in the nucleus. Now remember, protons and electrons correspond. So when we're doing our Rutherford-Bohr model, 6 is important. So we're going to draw our nucleus first. And there are 6 protons. Protons have a positive charge, and that is our nucleus, 6 protons. Then I look at the next data, number of electron shells. So I have 2. So I'm going to draw 2 shells, 2 circles around. Now, just like in Lewis dot, I'm going to use the number of valence electrons, and valence electrons are my outer circle always, my outer shell. So I'm going to do just like what I did with Lewis dot. I'm going to start here and I'm going to go clockwise, 4 dots. Okay, because there are 4 valence electrons, there are 4 dots on my outer shell. Now there are 6 protons in the nucleus, which means there are 6 electrons. I have 4 here. I'm going to put the other 2 on the inside shell. Doesn't matter where you put them as long as they're on that inside shell, and there is your Rutherford-Bohr model of carbon. So for our last example, we're going to use argon. So remember, argon is over there at the end in our noble gases family. And so we write down that the number of protons and electrons, its atomic number is 18. We know that it has 3 electron shells because it is in period number 3. And then we also know that the number of valence electrons are 8 because of our Lewis dot diagram that we just did. So let's construct our Rutherford-Bohr model. So again, same thing we did last time. We are going to create our nucleus. So our nucleus is going to have 18 protons. And we know that there are 3 electron shells. So we're going to do our 3 electron shells. 1, 2, 3. And we remember that our valence electrons always go on the outside shell, and there are 8 of them. So we do our clockwise method like we did for Lewis dot. That's 4, 5, 6, 7, 8. Okay, so I have 10 left over. Okay, and now I know also that if I follow the proper notation, the first shell will always work our way inside, has 2 maximum. Okay, so I'll put my 2 on the innermost shell. So that leaves me with 10. So now I have 8 left over, because remember 18 protons, sorry, is the same thing as saying 18 electrons, right? Because we have these neutral atoms. So I have to fill up the rest. So I have 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have all 18. And this is as big as it gets, really. I mean, the noble gases are pretty full. So, and that is our Rutherford-Bohr diagram for argon. And there you have it. Part 2 of the periodic table of elements, where we talked about the chemical symbol, the atomic number, the mass. We did Lewis notation and the Rutherford-Bohr model. So if you are still a little unsure, I would recommend going back and checking them out again and doing all those practices. Otherwise, I'll see you at our next crash course.